Question 3, Figure 3.1 shows a model of a wind turbine used to demonstrate the use of wind energy to generate electricity. The wind is blowing toward the model as shown. In part A, the mass of the air passing through the circular area swept out by the turbine blades each second is 7.5 kilogram. The kinetic energy of the air that passes through the circular area each second is 240 joule. In I calculate the speed of the air, there is one equation linking all of these terminology, the kinetic energy and the speed and the mass, because all of these are given and only one unknown, which is the speed. The formula is the kinetic energy equals half mv squared. To get the v as a subject, because this is the only unknown, as I said, so we made a cross multiplication. So 2 times the kinetic energy divided by m, and do not forget to make a square root. So to rearrange the equation, v equals the square root the 2 or double kinetic energy divided by m equals square root again 2 times 240 divided by 7.5. Finally, using the calculator, it gives us 8 and the unit, which is meter per second. The 3 marks for I is 1 for rearranging the equation and 1 for the correct substitution using the given information, and finally for the correct answer with the unit. Do not forget to use the significant figures. Here the question, the mass is given as 2 significant figures and the kinetic energy is 2 significant figures as well. So I'm advising my student to use this 2 significant figure or 3 significant figures. It depends on the question. Here, which is the 2 significant figures. In part A, double I, the kinetic energy of the air drives the generator. So there is a work done because we change the kinetic energy as an input in a form of the electrical energy. Okay, so the examiner is asking to state the input power passing through the turbine. So there is one formula for calculating the power, which is equal to the energy divided by the time taken. This energy, it was given in part A, it was 240 divided by the time taken, which is 1 second. This is from section AI. So finally, it gives us the input power, which is 240, and instead of writing joule per second, we use the SI unit, which is watt. So there's 1 mark here for the 240 watt. In section B, the output current of the generator is 2 ampere. So wow, now the examiner changed the question totally. Okay, we understood from the previous idea A that the kinetic energy as an input converted in a form of the electrical energy to make the generator works here, or to get an electrical energy as an output. So the examiner is taking us from the block 1, which is energy, power, or an energy work theorem, to a new block, which is electricity, the block 4. So the output here, potential difference, because we have voltage, which is 11 volt as an output here. And now the examiner is asking again to calculate the output power, not the input one. So the output power equals to I times V, which is a new formula linking the electric current and voltage. So I times V equals the 2 for the current, 11 for the voltage. It gives us 22 watts. And as usual, the 2 marks, 1 mark for the correct substitution and using the formula I times V, and 1 mark for the 22 watt. For part B double I to calculate the efficiency of the wind turbine. Efficiency equals to the total useful output power divided by the total input power. Okay, so which is equal to, if you remember these two numbers we just calculated in the previous two section, A and BI. So the 22 for the electrical one divided by 240, which is the kinetic energy as an input from the winds. And finally, times 100, so it gives us the percentage, which is 9.2. I think this one is low efficiency. For section C, the density of the air is 1.3 kilogram per cubic meter. And to calculate the volume of the air passing through the circular area swept out by turbine blades each second, so the volume equals. There's one formula linking the mass and volume. So we know the mass from the first part of the section A. So the mass divided by the rho, which is a symbol of density. The mass is 7.5 divided by 1.3 here. The 1.3 for the density and 7.5 for the mass equals 5.8, and the unit, which is cubic meter.